So we want to find approximate solutions to 2 sine x equal 1 minus 2 cosine x on the interval from 0 to 2 pi. Well, looking at this, I've got a sine x term and I have a cosine x term, and I don't have an identity to connect those. I do have an identity so I could substitute if they were squared, but they're not. So what I'm actually going to do is move those two trig functions to the same side. So I have 2 sine x plus 2 cosine x, and that will equal 1. And then I'm actually going to factor the 2 out because I think this will make it a little easier to work with. So if I factor a 2 out, I will have sine x plus cosine x equals 1. And in fact, I'm going to divide both sides by 2 to get rid of that 2. Now I have sine x plus cosine x equal a half. And what I'm going to do is I'm going to square both sides. And why I'm going to square both sides is because if I have a sine squared x and a cosine squared x, I could sub in for one of those using the Pythagorean identity. Now when you square both sides, you have to square the whole side. So this will have to be squared and this will be squared. And another thing to remember, if we square both sides of an equation, negatives disappear, and it's possible in the end I could get extraneous solutions that solve the squared both sides equation but don't solve the original equation. So when I get solutions to this, I'm going to need to check them to make sure that they solve my original equation. So this will need to be FOILed, the left hand side, because it has two terms. First term squared is going to be sine squared x. If we multiply these together, we get sine x cosine x, and that's outers and inners, so there's going to be two of those. Sine x cosine x, and then last times last will be plus cosine squared x, and that will equal squaring the other side 1/4. Well, I see one of my favorite trig identities here. I have sine squared x plus cosine squared x, so that will equal 1. So let me rewrite what I have. I have 2 sine x cosine x equals 1/4 minus 1, because this combined to be a 1 and I went and subtracted it on that side. Now looking at that equation, I see a couple of things. The left hand side's kind of crying out to me that I could use a double angle identity on that, so I'm going to do that. I recognize that as sine 2x. Now the right hand side will be 1/4 minus 4/4, so minus 3/4. Well, now we are down to a trig equation that we can solve, sine 2x equaling negative 3/4. So I am going to get the calculator and do inverse sine, and remember when I do, I get theta, and then I'm going to replace it with 2x in a minute. So let's bring up the calculator and make sure I'm in radians. And so I'm going to do inverse sine of negative 3 divided by 4. Now what that gives me is negative, we're going to carry it to 4 places in our work and then we'll round it later. So negative 0.8481. So negative 0.8481, and then we would put plus 2 pi k if we were after all solutions there. Now remember, when I do inverse sine, it gives me an answer in either quadrant 1 or 4, and it gave me an angle in quadrant 4 because it was negative. So where else would have the same sine value? Somewhere over here in quadrant 3. And so if I have this negative angle, I can see that I can get at the angle I want in quadrant 3 if I do pi and minus that negative angle, which would be adding that angle. I could have the angle I need in quadrant 3. So I'm going to take the calculator and I'm going to do pi minus the negative angle, which will make it a plus, and I will have that quadrant 3 angle. So I've got pi minus the answer, which is the angle that's in there, which is the negative 0.84, and I get 3.9, and we're going to round it to, it looks like 90. So my other answer is 3.990 plus 2 pi k. Now remember, those are the all answers if it would have been theta, but it wasn't theta, it was 2x. So I need to divide everything by 2 to find out what x equals. x would equal negative 0.42405 plus pi k. That would generate all answers for that particular angle. And then if I divided this one, I would have 1.995 plus pi k. Now, as I look to see what I need solution-wise, I need solutions on the interval from 0 to 2 pi. So first of all, negative 0.424 is not on that interval, so I'm going to add pi to it to get a solution that is, and I could also add another pi to that and I would still be on the interval from 0 to 2 pi. So we're going to get those two solutions. And so first of all, I'm going to have negative 0.42405, and I'm going to add pi to that, and I get 2.72 to 2 decimal places. So x equal 2.72. And then I'm going to get another answer by taking that and adding pi to that. So I'm adding pi to that, and I get 5.859. We're going to go to 2 decimal places. 5.86. So this one is 5.86. And now from this other angle, I get, if I round it to 2 decimal places, that's going to be 2. And then I'm going to add pi to that. So that's going to be 5.14. So we have 4 possible solutions to this trig equation. But remember, we said that when you square both sides, you can get answers that don't work in the original equation. So let's go back to our original equation. 2 sine x will equal 1 minus 2 cosine x. So we're going to check these angles and make sure that we get a true statement, and if we don't, we're going to have to throw them out. So I'm going to pull up the calculator, and I am going to put in there first 2 sine of 2.72. Now we rounded, so these might not be perfect, but there's the left-hand side. We're going to go to 2 decimal places, 0.82. So let's try the right-hand side. 1 minus 2, and that's cosine of 2.72. And that gives me something completely different, 2.82. So we got to throw this one out. Now let's try 5.86. That's going to be under the calculator a little bit, but 5.86. So the first thing I want to do is I want to do 2 sine of 5.86, and I get that answer. Then I'm going to do 1 minus 2 cosine of 5.86, and rounded to 2 decimal places, I get the same answer. So this one is good. 5.86 is one of my answers. Now I'm going to check 2. So I get the calculator and I do 2 sine of 2 and get an answer. And then I do 1 minus 2 cosine of 2. They're close. And we probably should have carried them out a little bit further if we wanted to see them accurate, but it looks to me like they're going to give me the same thing. This is due to rounding errors here, but we're close. So I like 2. Now I'm going to try 5.14. Okay, so I've got 2 sine of 5.14. We actually probably should have carried these about 4 places to have the accuracy here to 2 places by the time we're done. And then we're going to have 1 minus 2 cosine of 5.14, and that gives me completely different answers. So this one is also extraneous, and I have 2 solutions, 5.86 and 2.